Hello, everyone, and thank you for joining us today for this technical walkthrough of Swaylend. As a reminder, Swaylend is one of the 4 dApps for which Immunefi has set up an invite-only program. This means that all whiteheads who have found at least one vulnerability on fuel can submit a report in this IOP. We are excited to have Vic from the Swaylend team hosting this session today. Vic will guide us through the main functionalities of their code base and share valuable insights into their protocol. From Immunefi side, I'm Daniel, and I'll be hosting this event with Vic. Additionally, I would like to remind everyone that Swaylend is already live with a $45,000 reward pool for bug hunting in their smart contract assets. That being said, Vic, over to you for the technical walkthrough.
Perfect. Let me share my screen. Can you see my screen?
Yes.
Okay, perfect. So, hi everyone. My name is Vit. I'm the technical lead from the Swaylend team. So Swaylend is the first landing protocol on the fuel network. So I think that everyone here is already familiar with the fuel network. It's a new layer 2 roll up for the Ethereum. The mainnet for the fuel network is coming very soon, and the Swaylend is going to be one of the first dApps on the network. So Swaylend is a landing protocol, which means this is one of the core DeFi protocols that will be available on the fuel network from the day one. Swaylend is based on the architecture of the compound. So basically, if maybe I summarize the landing protocols in short, we have 2 roles of the users in the landing protocol. So we have suppliers and borrowers. So suppliers can supply the base asset of the landing protocol, which is normally a stablecoin, for example, USDC. And on the other hand, we have borrowers who are borrowing this base asset. And because Swaylend is based on compound architecture, the borrow amount has to be collateralized within the Swaylend protocol. So this means that you have to put some collateral assets, which is going to be an Ethereum and probably the derivative of the Bitcoin at the beginning. So you can put the collateral asset and then you can borrow some stablecoin based on the amount of the collateral you put into the protocol. So this is our landing page. I'm just going to go over some of the links and documentation we already have live, and you can already see it today, and over some of the development tools that we are using. And after that, we are going to dive a little bit into the code and into the smart contracts. So this is our landing page. You can see some basic information on this website. So this is not very interesting for you guys. Apart from that, we already have documentation live. I think that the link to the documentation is on the Immunefi page. So here in the documentation, we just go over what is the landing protocol, what can you do with it. You can read through the documentation to get more information about that. We also have some of the useful links on the documentation to our Discord, where you can ask questions aside from the Immunefi Discord, and also to our GitHub. What's interesting here on the documentation, so we have this for the developer section where we have the contract overview. If you want to get an overview, high-level overview of the contracts, we have the contract methods explained in the documentation. So basically, these are all the methods that can be called. These are all the methods on the Swaylend protocol that can be called by the users and also from the other smart contracts. Each method also has a description. And also in the documentation, apart from that, we also have the contract storage section where all the storage variables are also explained here. So if you want to get more information about the methods and functions, I suggest you to check the documentation page, but there are also some comments in the code as well. Next, we have the dApp itself. So basically, we are currently live on the Fuel testnet. So we are not yet live on the mainnet because mainnet was not released yet. So basically, this bounty is currently live only for the smart contracts, but when you are going to test the functionalities, you can also test it over the front end. So it's a very similar lending dApp where you can connect with your wallet. So we suggest using the Fuel wallet for that at the moment. You can connect with the wallet, then you can supply and borrow assets. Because we are on the testnet, we have this faucet page directly live on the dApp, so you can mint some tokens in order to use the dApp. So we have this borrow tab here where you can borrow the assets, and we have this earn tab where you can supply the assets. And we also have the market page where we have some statistics about the lending protocol. At the moment, we have two markets deployed. One is for the USDC and the other is for USDT. And this data, which you can show here, is the testnet data. So what can happen is that we are currently developing some new features before the mainnet, and we are redeploying the smart contracts every few days. So you can expect that this data can be reset in the coming days. And if you click on the separate market, you can also see some information about the market itself here, some statistics, and a lot of these values are also read directly from the smart contracts or from the indexer, where we are using Envio to parse through the logs emitted by the smart contracts. So for the development of the smart contracts, we are using the standard development tools provided by the Fuel. So this is basically the main Sway repository. Here, I don't know how familiar you are with that, but here you have all the instructions how to install and the tool chain for the Sway. So basically here you can install the compiler, which is a fork, and you can also use this fork for the deployment of the smart contracts and some other testing. In our repository, we are writing tests in Rust. So for that, we are also using a lot of Fuel's Rust SDK, which is also open source, and you can find also more information about the SDK on the GitHub. If I go to our repository, so our repository is live and open source from the last week. We currently have the mono repository structure, which means that all the code is in the single repo, which was much easier to set up and later use for the development, because we have some dependencies between the sub projects we have. So basically in this repository, we have smart contracts, which we are going to look more in details today. But we also have some other services which we have in the folder apps. So we have indexer code here and also the front-end code here. But for this bounty, this is not relevant at the moment. So you can find more about the project structure here in the README. And in the next part, I'm going to dive a little bit deeper into the smart contracts, which are the main thing for today's walkthrough of the code. And I'm going to share the Visual Code now, Visual Studio Code. Okay, so here is our repository. I suggest if you are when you are going to look for the bounties, that you are looking at the branch develop which has the latest changes, as we are doing the updates on the daily basis. So basically, if we look at the fork.toml file, we can see that there are many projects in our workspace. So for this bounty, there are only two projects that are relevant. So the first project is Market ABI, and the other project is Contracts Market. And this Contract Markets project contains all the functionalities and core logic of the landing protocol. So if we go to the Contracts and Market folder, this is like the classic fork project with the tests written in Rust. And inside the source folder, we have two files. The first file is main.sway, and the other is events.sway. So in this file, which we are not going to look into the details, here are only the structures of all the events that we are emitting in our contract. So the main file is actually main.sway, which is our main, which contains the logic for a landing protocol. And I will just go over this file a little bit. So we have some configurable variables which are set during the deployment of the contract. Then we have some storage variables. So basically, how our landing protocol works is that we are storing all the stats for each user. So for example, how much of the asset they are supplying or how much of the assets they are borrowing. This is all stored in the storage. So this is a little bit different than some of the other landing protocols where your position in the landing protocol is based on of these liquidity tokens or some other assets are minted about your position. But in our example, the position of the users is stored in the storage variables. And then we have the implementation of the ABI interface for the market. So this ABI is defined in the folder ABIs, Market ABI, Source ABI. So here are essentially all the functions that are also described on the documentation page. And apart from the ABI, we also have the structs file, which contains all the data structures that are used in our market smart contract. So basically, this is the market configuration. So basically, this is the configuration that is set for the whole market. So basically, there are a lot of configurable variables. For example, most of these variables tell you how the API is calculated for the suppliers and for the borrowers. It also contains the information about the base token of the market, which is, as I said, usually a stable coin. In our example, in our case, it is the USDC. And there are some other variables, for example, target reserves, which is the value which is important for the reserves of the landing protocol. If you're interested in more information about how exactly the landing protocol works, we don't have enough time here on this call, but there is a lot of valuable books and resources on the internet. And our landing protocol is based on the compound architecture. So I suggest that you look for the compound landing protocols specifically. We also have collateral configuration. This structure holds the configuration for all the collateral assets. So each collateral asset, this is like Ethereum or Bitcoin, needs to have some parameters as well. So this is like borrow collateral factor, liquidate collateral factor, and liquidation penalty. And these variables are also explained on our documentation page. And there are some other data structures, such as post configuration, user basics structure, which holds the information about each user, and some information also for the whole market as well. So basically, this also contains how much is the total supply of the landing protocol and how much is the total borrowed amount of assets in the protocol. And we also have the price data update structure. This is relevant for the Oracle. We are using the Pith Oracle. which is one of the oracles that will be supported on the fuel network. And we are going to check later how we are using the PIF protocol in the code base. Okay, so I will go back to the main contract where we have all the logic implemented. So I will not go over each function. I will just briefly describe how the contract is constructed and how it works. So basically, the market contracts is also has the ownership standard of the fuel implemented. So this is like Sway request for comment 5, so SRC5, which defines how the ownership of the contract must be implemented. So we have at the moment this implemented. So for example, if something goes wrong, or if there is some unusual behavior, what the owner of the contract can at the moment do, it can pause supplying and absorbing of the assets, and this is for the security reasons. And this ownership will be renounced as the lending protocol is more tested and stable in the future. And so basically we have one function in the market which just activates the contract and starts the market, which contains the market configuration and the identity of the owner. And this is called the first time the market is created. Other than that, this contract contains all the basic functionalities of the lending protocol. So this is like adding collateral assets and some other functions which handles the collateral assets. Then we have functions for supplying the collateral assets. We have functions for withdrawing collateral assets. Then we also have functions for supplying the base assets. So this is the stable coin. This is for the suppliers of the protocol. We have the function withdraw base, which is called by the borrowers of the protocol, or also the suppliers when they want to withdraw the base asset they supplied. So one of the interesting things about the compound architecture which we are using is the liquidations. So basically, liquidations are a very important part of the lending protocols, and they happen when the price of the collateral asset suddenly drops, which means that the borrowed amount of the USDC by the borrowers is not collateralized anymore, because the collateral asset that I provided for that borrowed amount is now worth less because the asset price dropped. So that's why you have to do the liquidations of the lending protocol. And how the liquidations work in our case is that there are two functions that handle liquidations. So the first function is the absorb function. And this absorb function actually absorbs the collateral assets from the borrowers. And so basically, these collateral assets are then held by the smart contract of the protocol. And in the next step, anyone can then buy the collateral asset from the protocol with the base asset. And so basically, so basically how the liquidations work in the more details, it is also explained in the compound documentation and in our documentation as well. I just want to mention that for the liquidations, there are actually two functions that need to be called. So the first is absorb, and the next function is, so the first function is absorb, and the next function is buy collateral, which is here. And so these are like the functions from the ABI that we implemented, and we also have some other functions which are not in the implementation of the ABI brackets. So these are some of the internal functions where we have some core logic implemented. So here I just want to mention a little bit about Oracle we are using. So we are using the Pith Oracle. Pith Oracle is the push Oracle, which means it's a little bit different than the pull oracles, which is the chain link. So basically, the push oracle works in a way that when you need to access the price of some asset in the dollar value, in the USD value, for example, the USD value of the Bitcoin, this has to be used, for example, when you're borrowing the base asset. So we have these extra parameters in the functions, which is the price data update. And actually how this works is that users, before they call this function, they need to get the price of the Bitcoin from the PIF network. And this data is cryptographically signed by the PIF network nodes. And inside here, when we have this price data update, we are calling the PIF smart contract on the fuel network, which updates the price of the asset with the so this is like here, this is this function which updates the price of the asset on the PIF or on the PIF smart contract. And this is actually provided by the users, but the users must always provide the data from the correct source, because this data is digitally signed. So if users just, for example, they made up some price, this price would not be accepted because it was not signed by the PIF network. And there is a lot more information about how the PIF oracle works, also on the documentation of the PIF network. Yeah, there are some other things that we have in our code base. So for example, we are using the reentrancy guard, which is implemented in the Sway libs, which is the repository of the different functionalities that the Sway team already implemented. So we are using also the signed integers from their library and other ownership and reentrancy functionalities. There is also, this is actually everything I have for the smart contract. If you have any question, I think there will be time for the questions after my presentation. So if I go back to the market project, we are deploying this market contract with the proxy. So in the first few months, we will have the upgradability enabled. So basically, if there will be something wrong within the code, we will be able to pause the functionalities, upgrade the code, and then this will be done through the proxy pattern that is also supported directly within the fork and the dev tooling provided by the fuel. And for the testing, we have this folder tests, where we have all the tests written for the market contract. So these tests are written in Rust. So basically, we have two kinds of tests. So first, we have these folder scenarios where we have each functionality tested separately. So for example, we have the test for liquidations. We have the tests for absorbing and buying collateral. We have tests for reserves. We have tests for supplying and withdrawing the base asset and also for the collateral asset. So basically, each functionality is tested separately in each of these files. And then we have, next to that, we also have main test uni, where we actually have, I think there are around 10 steps, which basically just goes through all of the functionalities of the lending protocol. And there are also multiple wallets created. So basically, you have different users doing different actions, and basically all the functionalities are tested. So these are our main tests for the lending protocol. And we also have this market configuration here defined in this config.json file. So these are all the parameters of the market that are set up. And in the separate file, we have the information of the collateral assets and the base asset, again, with all the parameters that are needed for each of these assets. And yeah, so basically these tests are all written in Rust. and that therefore we also have cargo.toml, which is the standard thing in the Rust development ecosystem. And the last thing that I want to mention in our repository is this scripts folder. So in this scripts folder, we have the scripts that are used to deploy the smart contract on testnet, and it will also contain the scripts for the mainnet. So basically here we have just scripts that can deploy the smart contract. They can update this smart contract. We also can update the collateral assets. For example, if we want to add a new collateral asset in the future, we can just call this script and it will do the magic. And we also have a README which just, maybe if I can put here, it just goes over all the scripts and how we are deploying the smart contract with proxy and all that. And we also have these configs, which are actually the configuration values we are already using for the testnet, and it will also contain the configuration values for the mainnet. So this is how our testnet configuration looks like, and it's all in the repository and open source. And yeah, this is actually everything from my side for now. And if you have any questions, I'm happy to take them.
Thank you so much, Vic. Thank you very much for this in-depth walkthrough. Before we dive into the Q&A session, I'd like to ask a few questions to help our SRs better understand the best approach, identify any vulnerabilities. And here's the questions. What unexpected bugs have you encountered in past audits, and how did they impact your security assumptions or threat model?
Yeah, so basically, one of the interesting things that we have in our smart contracts is the use of the signed integer. So basically, we have to use the signed integer for the user's positions. So basically, when the user supplies the USDC, they have a positive number, but if they are borrowing the USDC, they have a negative number. So one of the things that we were using like 2 weeks ago, we have our own signed integer library, which can be tricky to implement. And we have one vulnerability in this library for the signed integers, but 1 week ago, or I think it was 2 weeks ago, we switched to the Swaylend implementation, which became more stable and audited from the Sway team as well. So basically what I want to say is that there are a lot of variables that needs to be stored inside the structure, inside the structures for the user positions, and all these variables are basically because you have to store floating numbers as integers. You have these like very big numbers with 18 numbers with 50 numbers. It basically depends on what kind of variable it is. So what you have to be very careful when you are doing these operations inside the smart contracts. You always have to be careful when you are multiplying the numbers. You have to be careful that you are multiplying the numbers which have the same number of decimals, because if they have a different number of decimals, you need to divide by some factors. And this is like one of the things that you have to be very careful when you are doing calculations inside the smart contract. And that's why when we were using the signed integer with our library, we decided to switch to the Swaylib library. So there are no unexpected behaviors when you are doing this multiplication with big numbers.
Okay, thank you so much. And the next question would be, what key areas should backenders focus on and why?
Yeah, so that's a great question. So basically, one of the things that you have to be careful is that we have this owner which can set up the configuration of the lending protocol. So there are a lot of functions are basically guarded by only owner function. So basically adding new collateral assets, pausing the collateral asset, resuming the collateral asset, and many other functions, for example, also withdrawing reserves, are guarded, so only the owner can call these functions. And there are some functions that can be called by basically each user, which is like buying collateral during the liquidations. There is also like withdrawing the base asset, supplying the base asset. These can be called by all users, but you have to always be careful that you check all the conditions of the lending protocol if some user can actually borrow the asset. So if he provided the collateral asset and he's not borrowing too much of the base asset. So there are a lot of different actors in the system. So you have suppliers, you have borrowers, then you also have the owner, which can update some configuration of the market protocol. So there are a lot of different aspects you have to be careful when you are. So who can call which function, in what order can some functions be called, and things like that.
True. Any tips from your team on what to look for in your code base?
Yeah, so one thing that is that we are very careful about, which is also like the thing that a lot of DeFi protocols are why a lot of DeFi protocols are exploited is the use of the Oracle. So basically, always when you are relying on some other smart contracts, we are relying actually on the data, which is the dollar value of the asset. So basically, we are relying on the data that is not native to the blockchain, which comes from the other source outside of the blockchain. So we have to really be careful that we are using the Pyth oracle in the correct way. We also validate a lot of values. So for example, when someone updates the price of the asset, we need to be careful that this price is not too old, or maybe this price is not like ahead of the block timestamp of the fewer blocks. So there are a lot of caveats that we have to be careful about when we are using the oracle and when we are getting the price from the Pyth smart contract. So this is like one of the things that you have to be really careful about is the Pyth oracle. And the other thing is basically all the statistics that you have about the lending protocol and which are stored in these structures. You have to be very careful that you are keeping track of all the supplied assets, of all the borrowed assets, and you are keeping the track of them in the correct way. And you are also then allowing only the users that provided these assets, that only they can also withdraw these assets, and they can only withdraw as much assets as they provided and that actually belongs to them.
Okay, and what resources on top of what you already described at the beginning of this call would you recommend to learn more about your project and code base?
Yeah, so basically I shared a lot of resources already at the beginning. So basically I would suggest checking of course, our GitHub repository and also our documentation page. But because our lending protocol is based on the compound architecture, I also suggest checking everything you can find about the compound lending protocol and how it's structured. Our lending is a little bit different, but the main idea is basically the same. So I suggest also just Googling lending, DeFi lending protocol, how it works in details. There is actually a very good book from the Rare Skills, which also explains all the functionalities in a very detail and with examples.
Indeed. And the next question will be, what are the different access control roles within your protocol?
Yes, I already mentioned that. So basically, as I said, we have suppliers, borrowers, and also the owner of the smart contract. So as I said, suppliers can do a certain thing, borrowers can do some other things, and the owner can update the configuration and can upgrade the smart contract in case there is a bug found in one of the functions.
Okay, thank you so much for repeating that to our listeners. And which areas of your code in your code base do you expect to be most challenging for auditors, and where are bugs most likely due to implementation complexity?
Yeah, that's a good question. So I think that the hardest part of the smart contracts are the the calculations, like the calculations of how much. For example, if we go to these update based principal functions, there are a lot of calculations where you need to multiply different parameters of the market and calculate. For example, during the liquidations, you need to calculate how much is the liquidation penalty. You need to multiply this with the how much the user is liquidated, and you have all these parameters and calculations, and you need to then update the statistics for the users. And this is also during the absorbing of the user's assets. You have to iterate over all the collateral assets that are provided by the user, and you need to calculate a lot of things. So basically, this is like the hardest part of the protocol, is just calculating how much assets you can you take from the users when he's liquidated. Then you have to absorb these assets into the protocol. You have to give the borrower something back. You have to update his user structure in the protocol and things like that.
All right. Thank you so much for this additional details. Now let's jump to our Q&A session. So would like to extend to everyone who's joined this call the possibility to make any questions live so that Vic can respond and clarify. So Jesse Poe says, which part of the code is most different from compound?
Yeah, that's a great question. So basically, the things that are most different from the compound protocol are actually things that are very specific to the Sway. So basically, the assets, how are handled, is different in the Sway that is in Solidity. So basically, here we have native assets, whereas in Solidity, you have the ERC20 tokens. So there are some caveats about how these assets are transferred, how they are stored inside the smart contract. They are these are some of the differences. Then the other differences is that we have a little bit different ownership pattern than there is in the compound architecture. The third difference is that the compound is using chaining on the EVM networks, while here we are using the PIF oracle. So PIF again is a thing that is quite different than it is in the compound architecture on the EVM networks. But like the underlying logic itself is somewhat familiar. There are a little bit differences because, for example, in the Solidity, the native integer type is the 256-bit integer, while in the Fuel network VM, you have the 64 bits integer. So we have some, because of that, we had to make some changes to the calculations when we are doing with the decimal numbers, with these big numbers. But yeah, the first three things I mentioned are most different from the component.
Okay. Yeah. So I was about to ask Jessica, does that answer your question? But your thumbs up does reply to my question. So any more questions? I can check on our Discord channel whether we have any question on that side, but I don't see any questions there. Let's give some more minutes to our SRs to formulate or think about any other questions. Well, I think that's it. I would like to thank everyone who attended live. Oh, hold on, Jesse says. My typing. What are some calculations scaled to 18 decimals instead of 15, like, for instance, utilization of the supply and borrow rates?
Yeah, that's a good question. So basically, this depends on how complex the calculation is because if you multiply a lot of numbers between themselves, you need to have that bigger precision than when you are doing some simpler calculations. So basically, if there are more numbers multiplied between each other, and you have to have this higher precision, we are using 18 decimals. But in some other cases, when it is a simple index that you multiply with one number, we are using the 15 decimals.
Cool. Any more questions? Still have some minutes available to us.
Maybe I can just say one thing.
Sure.
Another thing that is different from the compound is that in the EVM networks, the ERC20 tokens usually have 18 decimals, while in the fuel, the assets have 9 decimals. So this is also one of the differences between the Swaylend and compound. But this is more like the difference between the networks than the protocols, lending protocols.
Okay. Guys, do you have any other questions so we can take advantage of Vid knowledge to reply and have a detailed explanations? Perfect. All right. I think we don't have any other questions. It was great to have you all here. Glad we had such a productive session. As I said, we have set up an open channel on Discord with the entire Swaylend team. So if you have any follow-up questions, feel free to join the discussion there. Again, also, the recording of this call will be posted by tomorrow at the latest. So if you would like to review any details regarding the explanation, the recording will be right there for you. Once again, thank you all and happy hunting.